if you assume any improvements at all over time, then games will be indistinguishable from reality.
For thousands of years, we have wondered about our place in the universe. From the first cavemen to enter the Stone Age to the astronauts taking humanity's first footsteps on the moon, we have grown ever more curious with every new thing we learn. While attempting to extend our reach across the stars and strengthen our understanding of the cosmos, we have always asked ourselves questions such as, are we alone? Where did we come from? What is our true purpose? However, today we will focus on asking ourselves the question, what if everything we know is fake? At the beginning of the modern era, Erwin Schrödinger was having a conversation with the renowned physicist Albert Einstein. It was in this conversation where Schrödinger had the need to explain his problems with the Copenhagen interpretation of quantum mechanics. In order to explain these problems, he led Einstein on perhaps what is the most famous thought experiment of all time, Schrödinger's cat. Long story short, Schrödinger's cat imagines a sealed box that contains a cat, a flask of poison, and a Geiger counter connected to a radioactive source, such as the nucleus of an atom. At any point, the atom could decay, causing the counter to increase, and if this were to happen, then the flask would shatter, and the cat would be poisoned. The intrigue of this thought experiment comes in determining whether the cat survives or not. Since the box is sealed, there is no way of observing either the Geiger counter or the cat. As time goes on, the likelihood of the cat's survival decreases. However, it never fully reaches zero. Because of this, the cat is in a state of superposition, being both dead and alive, and it will remain in this state until the box is open and an outcome is observed. While it would take years for the accomplishments of this experiment to be realized, there is no doubt that it sets a precedent about the uncertainty that quantum mechanics adds to our world. Transitioning to nearly 70 years later, 2003 saw the first formally published papers highlighting these uncertainties and shedding light on a new possibility for the universe's secrets. The paper, titled, "Are You Living in a Computer Simulation?" is one of the most recognized works of Nick Bostrom, a Swedish philosopher and theoretical physicist who works at the University of Oxford. The argument introduces three propositions, of which at least one is to be true. The first argument: civilizations go extinct before they can create a simulation. The second argument: any advanced civilization has no interest in simulating their ancient history. And the third argument: we are almost certainly living in a computer simulation. Other propositions exist, such as the creation of universe simulations are not possible. However, for the sake of this video, we will be focusing on the original three. Bostrom wrote this paper on the belief that future civilizations can and will create simulations of their ancestors, and that they will create possibly up to thousands of these simulations. If these beliefs are true, and consciousness itself is able to be programmed into a simulation, the likelihood of us living in base reality is resoundingly small, creating an existential feeling in anyone who dares to imagine such a possibility. Much like the presence of a god, the simulation theory cannot be proven nor disproven. However, there exists a lot of evidence pointing towards our universe being completely artificial. Elon Musk, as seen at the beginning of the video, is an avid supporter for the simulation theory. He states that when he was younger, the most advanced video game was Pong, a game made up of just a few shapes and the most basic physics, compared to modern games which can take advantage of the possibilities offered by advanced software such as the recently developed Unreal Engine 5. In December of 2021, the first trailer for the new The Matrix Awakens game was launched, and we saw perhaps the first video game that many believed, to a degree, to be indistinguishable from reality. Take these video games mixed with the unseen future technological advancements in virtual reality and brain-computer interfacing, and we get video games that are real, or at least would be to any of its players. Think of it like a dream. If you dream that you're a bird, oftentimes you would not realize you're dreaming until after the fact. So how do you know that right now, you are not just a bird who is dreaming about being a human? This way of cheating consciousness would allow the creators of a simulation to trap sentient beings inside without them knowing any difference. The deeper we dive into simulation theory, the easier it is to find things that seem like concrete evidence. The famous physicist Michio Kaku believes that humanity will last into the far reaches of the future. However, he is openly against simulation theory as he believes that the only computer capable of simulating the universe is the universe itself. He argues that simulating the vastness of the universe would require more computing power than scientifically possible. However, the backers of simulation theory have come up with a clever yet compelling answer to this argument. Video games more often than not only render the environment which a player can interact with. For example, on a busy street you would see buildings and vehicles, but unless you were to actually go inside of them, they are nothing but detailed facades. This same technique of saving computational power can be applied to a universe simulation. Along with this, video games normally have a constant limit on how much can be rendered at once. Many supporters of simulation theory say that this explains the universal speed limit of the speed of light. By spreading objects out by multiple light years and setting a cap on the speed of light, you are able to limit a civilization's potential to travel throughout space, at least in accordance with our current understanding of the universe. While this evidence is taken from artificial worlds, there exists a very popular physics experiment that has led many others to the same conclusion: the double slit experiment. By shooting tiny particles such as electrons or photons through two slits on a screen, you get two respective bars of light. However, when you are not observing the outcome, you would see a wave interference pattern on the screen. What does this mean? When you are actively observing the outcome of the experiment, you will see one bar of light for each slit, representing the particles passing through the slit onto the screen. But when the experiment's outcome is not being observed, the particles instead act as a wave, and due to the canceling out of one another would produce an interference pattern on the screen. This concept is known as wave-particle duality, and for hundreds of years this problem has stumped scientists, and even to this day it continues to hold back the secrets of the universe. Assuming the third proposition, we are almost certainly living in a computer simulation, is true, it is very interesting to think about all of the technicalities of creating and running a universe-scale simulation. A civilization could recreate a perfect replica of their own universe, or perhaps tweak just a few of the parameters to experiment, or even create a completely new kind of universe just to see what is possible. The danger of this assumption, as mentioned before, is that our chance of living in base reality would be near zero. At this point, the only question that remains is how deep does the rabbit hole go? What is the limit for how many simulations could possibly exist? How does time work relative to other simulations? How would someone prove whether or not they are in a simulation? The answer to the last of these questions is often regarded as you can't. But what about the few who do believe? They believe that in the reality of any universe, the concept of perfection will always be abstract. They believe that even in a simulation like this, one that is indistinguishable from reality, there are occasional glitches. Glitches in the simulation are the scapegoat for many psychological phenomena that we experience. Déjà vu is a French term to describe the feeling as though you have already lived through a present moment. Or the Mandela effect, a phenomenon where you vividly remember something in the past that is either different or completely wrong from what actually occurred. This is a prime example of the main attraction of the simulation theory. Much like a preacher arguing with an atheist, anything in the universe could be used as evidence to support your own belief. But as humans, it is within our nature to ask these questions, to search for a truth among the vast unknowns of the universe. So, are you living in a simulation? Probably not, but you'll never know for sure. If you enjoyed this video, please make sure to leave a like and subscribe. Let us know in the comment section down below whether you think we are living in a simulation or not. If we are living in a simulation, but we believe it is real, then what is real? Perhaps in a place like the universe, the term real doesn't exist. Maybe none of the terms we use to describe the universe really exist. Time could be a construct of our minds, and the universe a forever living entity that has no end nor beginning. Spatial dimensions could be but canvases for the laws of physics to describe concepts that we can't even begin to understand. You could spend a lifetime trying to prove the simulation theory and come up with nothing. However, on the other side of this coin, you could also wake up and find yourself outside of the simulation, experiencing true reality. But with this newfound discovery and awakening, the memories of your past and the remnants of the real you would more than likely fade away.
In the years since Huxley, science has learned a lot about brain activity, but the relationship between brain activity and conscious experiences is still a mystery. begin with a question. Do we see reality as it is? I think so. But could I be wrong? Could I be misinterpreting the nature of my perceptions? We have misinterpreted our perceptions before. We used to think the Earth is flat. Then we thought that the Earth is the unmoving center of the universe. Once we let go of our massively intuitive but massively false assumption about the nature of reality, it opens up new ways to think about life's greatest mystery.
If you're like most people, then you have a house, a family, and possibly a job. All of your days are filled with work and chores, and once you're finally ready to relax, it's time for bed. As time goes on, the repetition and monotony of daily life often leaves you wondering, what the hell am I even doing here? From the sunniest summer days to the coldest, driest days of the winter, and from the happiest moments to the saddest experiences, these are the kinds of things that all of us humans can relate to. Even though our lives are filled with hardships, we look on the bright side and focus on our values and growth. While your answer to this question is likely different to others, it is likely that at some point you have come to your own conclusion. And although we all have our own beliefs about existence, one thing we can all agree on is that nothing can be absolutely certain. In 17th century France, a young philosopher named René Descartes asked himself this exact question. However, to him, it was much more than just an afterthought of a long and stressful day. He spent years trying to come up with his best possible answer. While some of his thought experiments seem rather far-fetched, after watching this video, you will find yourself questioning reality itself. Although he was a very religious man, Descartes questioned the existence of a benevolent and all-good God. He believed that such a God would not deceive him under any circumstances. However, he knows from his own experiences that he has been deceived before, both by the world and by others. Because of this, there appears to be the possibility that a malevolent demon is instead in charge. A demon with the goal of deceiving us in every possible way, rendering everything we know completely uncertain. The evil demon thought experiment led Descartes to believe that nothing can be unconditionally trusted, and that everything he experiences ought to be questioned. A more modern and perhaps even more vexing thought experiment is the brain in the vat thought experiment. Reimagining Descartes' evil demon, Gilbert Harman introduced his brain in a vat thought experiment in the 1980s. Here we imagine an isolated brain that is placed in a tank of life-sustaining liquid like that found in the skull. The neurons of this brain are connected to a computer via electrical wires, and the computer sends electrical signals to the neurons identical to those found in an embodied brain. This would cause the brain to have a regular conscious experience, even though everything it knows is completely artificial and predetermined. Imagine you are a brain in a vat. Instead of being a true sentient being, you are just a spectator experiencing a universe that is completely designed and controlled by some external entity. At any point, they could alter your reality to their liking, or even unplug you from the computer, all while you wouldn't know any different. The overall consensus of this eerie thought experiment, the same as Descartes' from nearly 400 years ago. The argument goes as following. If you are not a brain in a vat, then everything you know is real. However, if you are a brain in a vat, then you cannot believe anything is real. Since both of these statements are true, and there's no way to prove you are not a brain in a vat, it seems like again we find a reason to question everything we believe. One of the main uses of this thought experiment is an argument for solipsism, or the idea that only your own mind exists for sure. While there are many different degrees of solipsism, the main interest for this video is the idea that there is no way of knowing for certain that anything outside of your direct experience is true. Other people could be NPCs tailored to fit perfectly in your uninteresting universe. All these stars in the sky placed deliberately to trick you into believing you are a small piece to a nearly infinite cosmic narrative. This seems both highly unlikely and even egotistical to believe. In the 1970s, Hilary Putnam sought out to this exact thought experiment to see what conclusions he could reach, and all of his findings led to the emergence of his own new, albeit compelling, thought experiment. It's called the Twin Earth thought experiment, and it was this. Imagine there is another planet on the other side of the universe that is identical to Earth. We have Bob living on Earth and Twin Bob living on Twin Earth. Both Bobs have the same job, live in the same house, and have the same families. However, instead of H2O on Twin Earth, the oceans are full of what we know as soda. Although on Earth this liquid is known as soda, everyone on Twin Earth still refers to it as water. When you ask the two Bobs the question, what are the oceans full of, they will both answer water. And even though they are speaking about different liquids, the neurological signals across the two Bobs' minds would be indistinguishable. This led Putnam to believe that one's frame of reference cannot be determined by the contents of their brain alone. Instead, we must explore the causal action that led to someone learning this term in the first place. When both Bobs were 4 years old, they went on a family vacation to the beach. It was here they asked their mothers the question, "What are the oceans full of?" And here, we would find a difference in the answer they received. This difference is enough to cause the frame of reference of Bob to develop separately from the frame of reference of twin Bob. This first causal action is the first of many that lead these two physically identical beings to have completely different conscious experiences. However, the point of these thought experiments are not to find some crazy theory to believe in or to explain the universe. Instead, to experience, even if just for a moment, the lack of any limiting beliefs or dogma. The school of epistemology that indoctrinates this theme is skepticism. In modern day, when you hear that someone is a skeptic, they often have a bad reputation of being wrongly opinionated or even just a conspiracy theorist. However, it has not always been this way. Since the teachings of Aristotle and Plato thousands of years ago, scholars have been questioning the perceived truths of the masses. Instead of arguing over an objective truth, the ancient skeptics highlighted the subjectivity in everything and chose to embrace the unknown as a goldmine for critical thinking. While being a skeptic in the ancient times was probably much different than today, we believe that now is the most important time for us to learn to question our reality. With the explosion of the internet and the digital world, every day we are bombarded with false information, from flat-out propaganda on the news to delusional perceptions portrayed on social media. It's impossible to escape these false realities. While there is nothing wrong with uncertainty, having too much that you cannot manage will lead you to developing many limiting beliefs and views of the world that almost definitely worsen your own conscious experience. By accepting that uncertainty is a major part of life and that just because something is unexpected doesn't make it any worse than something you already anticipated, you are able to open up new opportunities to experience reality in a more curious and secure manner. So don't lock yourself in your room and ponder the meaning of your existence. But it is important that with every decision you make, you take a second to evaluate who gets the final say. Is it the real you or just your perception of yourself? The largest galaxy that has formed since the supposed Big Bang has a mass of 3.75 quintillion suns. Our Milky Way a mass 2.5 billion times less. But this weight in terms of human brains is about this. In 1896, Austrian physicist Ludwig Boltzmann proposed a concept that would eventually lead to one of the most bizarre explanations for the origins of our universe, the Boltzmann brain. At this point in his life, Boltzmann was heavily invested in his studies of thermodynamics, exploring the natures of heat and entropy, and his work in this field laid the foundation for our current understanding of the physical world. Boltzmann introduced the concept of entropy as a measure of the disorder or randomness in a system, and he formulated the famous second law of thermodynamics, which states that in any closed system, entropy tends to increase over time. With the introduction of this new law, the realm of physics was given the all-encompassing concept known as the arrow of time. What is the arrow of time? Picture this. You have a clean canvas, and you decide to put a drop of paint directly in the middle. You observe the paint spreading until the whole canvas is covered. But why is it that we never see the paint go in reverse and group back into a drop in the center? If you were to zoom into a molecular scale, you would simply see the paint molecules moving around and colliding completely at random. However, the arrow of time, in a way, describes the likelihood of any outcome. Long story short, the amount of canvas covered by your initial drop of paint is much smaller than the canvas itself. As soon as the drop is placed, there are multiple new points of which the paint can expand to. And it just so happens that when all is said and done, these new points always outnumber the original points, hence making them always much more probable. But going back to the molecular scale, there is no reason that the paint molecules cannot randomly accumulate back into a single drop. It's just that this is all that it is, random. Given enough time, say this many years, you would see the paint form back together as one single drop. You would even see it perfectly replicate the Mona Lisa, and even create a portrait of you. This phenomenon is best described by the law of truly large numbers. In the context of this video, this law states that given a near infinite amount of time, any event that has a probability greater than 0 is likely to be observed. An example of this in our world is the irrational number pi. We all know that there are infinite digits in this number, but one thing most people don't know is how there are also all possible number combinations in pi. Your birthday, your phone number, even your exact DNA sequence translated to binary all exist at one point or another in the digits of pi. We know it is unlikely that a human or any living thing for that matter could live long enough to observe these number combinations or any highly unlikely possibility. The universe, however, still has a near infinite amount of time left. It is believed that once the universe has expanded enough, it will create a cosmic horizon, much like the event horizon of a black hole. This cosmic horizon, in a way, limits the reaches of the universe, creating a seemingly empty, albeit completely new, observable universe. And in the same way that the event horizon of a black hole emits Hawking radiation, this cosmic horizon would also emit particles or fluctuations inwards towards the new universe. After an amount of time so large that even numbers struggle to represent it, the last particle will be emitted, leaving a vast emptiness full of nothing but individual elementary particles, and finally we reach the final state of the universe. Or is it? The particles left over from the cosmic horizon, like any particle, undergo quantum fluctuations. But what are quantum fluctuations? When you zoom into a submolecular scale, you would observe random variations in the properties of any quantum system. The reason for these variations are best described by a concept known as Heisenberg's uncertainty principle. The uncertainty principle plainly states that we cannot know everything about a particle at the same time, like where it is and how fast it is going. Because of this, there are times when the particle might change in unpredictable ways, creating a quantum fluctuation. Now, the emptiness of this new universe is much like the emptiness of a fresh canvas. And if we zoom in, we see particles moving around and colliding completely at random. Eventually, given enough time, these particles will combine and form atoms, then molecules, until eventually they will recreate the entire universe as we know it. So, is it possible that we live in a sort of dream of a past universe? Possibly, but the chances of this happening are near 0. So by the law of truly large numbers, it might take a near infinite amount of time. However, if this is truly the final state of the universe, then time should be no problem, right? Well, let's explore another possibility of what the random motion of the particles could eventually lead to. While the largest galaxy that has formed since the supposed Big Bang has a mass of 3.75 quintillion suns, and our Milky Way a mass 2.5 billion times less, this weight in terms of human brains is about this. Why human brains? With our current understanding of the mind, a human brain is all that is needed for consciousness to emerge. So while it seems like the accumulation of matter forming a new universe is all but inevitable, what does this say about a universe that is full of floating, conscious human brains? This is a universe that in the big scheme of things would be much more likely, which brings us back to the original purpose for the Boltzmann brain argument. Ludwig Boltzmann believed that the universe is not as chaotic as it seems. He believed that in the universe's final state, it would spontaneously fluctuate to a lower entropy state, like that at the beginning of the universe during the time of the Big Bang. He came up with the Boltzmann brain hypothesis as a way to defend this theory, by the use of reductio ad absurdum, the form of argument that establishes a claim by showing that the opposite is, well, absurd, meaning that if the universe was in an ever-increasing state of entropy, then the emergence of Boltzmann brains is not only likely, but possibly even more likely than us being real creatures in the original universe. Renowned physicist Richard Feynman says about the Boltzmann brains, "It is the origin of all irreversibility that makes us remember the past and not the future," stating that we are only able to remember moments that occurred in a lower state of entropy or of higher order, further strengthening the arrow of time and its relation to entropy. While Boltzmann has undoubtedly changed the game when it comes to our overall understanding of thermodynamics, he is far from the only one to imagine an alternative source for our consciousness. The many worlds interpretation is one such alternative. It was proposed by physicist Hugh Everett, who sought to explain how the mathematics used in quantum mechanics related to physical reality. This interpretation basically states that all possible outcomes of a situation actually happen simultaneously in different parallel universes. Imagine you have a set of 10 dominoes. You are given the choice to either knock them over or to leave them be. According to the many worlds interpretation, whichever choice you make doesn't really matter, because there will always exist a universe where each different option is chosen. If you choose to leave the dominoes be, then in a parallel universe, your identical self will choose to knock them over. When all is said and done, only one event occurred in your universe, you choosing to ignore the dominoes. However, in the parallel universe, 11 events occurred, you knocking the dominoes over and each one of them falling. Now, replace the dominoes with any decision you have ever made in your life. One step further, with any decision any human has made, ever. Imagining such a possibility really highlights both how our universe is completely unique and how there seems to be an infinite number of universes with infinite possibilities. When this idea was first proposed by Everett, there was an immediate backlash from parts of the physics community. They call many worlds a theory instead of an interpretation. One of these opposers even said that calling many worlds an interpretation is like talking about dinosaurs as an interpretation of fossil records. However, despite the controversy, the many worlds interpretation, like many of the other interpretations, does a good job of helping us wrap our minds around the world of quantum physics. It could help explain some paradoxes that arrive on the tail ends of certain thought experiments, such as Schrodinger's cat. The massive number of possibilities that arise when considering these thought experiments and theories can leave us speechless, to say the least. Are you a Boltzmann brain floating through space right now, and you are just dreaming about watching this YouTube video? It's unlikely, but it is possible. Much like the emergence of life on Earth, extremely improbable, yet here we are as the only known intelligent life in the universe. But who's to say that it all stops here? You could be a floating brain in the vastness of space, or you could be a brain in a vat connected to a computer. The whole universe could be a computer simulation run by higher beings, or perhaps the most equally terrifying and inconceivable possibility, in the end state of the universe, much like that described by Boltzmann, the eventual accumulation of molecules could give rise to a type of computer. On this computer is a simulation of an entire universe, finely tuned in its own manner, giving rise to familiar concepts such as quantum fluctuations. And it is here that we find the perfect stage set for the endless reincarnation of the universe.